Hey folks, we are back for Falcon High School Chemistry.
Yes, podcast 2.4, still in scientific measurement, but we're going to talk about...
We're going to talk about the metric system.
Yes.
And the international system of units is called
the SI.
SI because it was made in France.
Oh, okay.
And there it's Système International. So, SI.
All right.
Right. Well, let's look at how to use metric units.
I need to know that.
Yes. And you've got a worksheet that has boxes like this. We're going to get to those in a minute. But sometimes I'm going to tell my students to ask King Henry about how to convert these units. And here's what I mean by that. Kilo, hecto, deca, deci, centi, milli. And my words got mixed up. Oh. So it works like this. King Henry died by drinking chocolate milk.
Oh, really?
No, not really.
Okay.
That's just what we say about him.
Okay.
So that we can remember the order.
All right, for conversion factors.
Yes. So if you remember how King Henry died, you'll know what order to put these letters in, and you'll be able to convert from one metric unit to another. So our students need to get out their Metric Mania notes. It's called Mega Metric Mania. It has all the boxes across the top like these ones. All right, and you've got yours, and they've got theirs.
Yes.
And so now, let's just work on that. Okay, so let's start with the basic unit.
All right.
We're going to put their meter, liter, and gram.
That's the basic, right, Miss Gray?
Yes. So meter is for distance or length. Liter would be for volume. And gram is for mass.
All right.
Okay. So in our King Henry method, this would be the part that says by. Basic unit is by. How did he die? By drinking
chocolate milk.
Okay, you want to go bigger or smaller?
Smaller.
Okay, we'll go smaller first. We're going to do the next three boxes.
Okay.
The ones that say drinking chocolate milk. So we need D.
By
drinking chocolate milk.
I thought this is clear for them.
Okay,
and
so for drinking, that's for deci. D-E-C-I. And its abbreviation is lowercase d.
All right.
And its meaning is 1/10. So underneath the box, will you please write 1/10, 1 over 10?
Right here?
Yes, underneath the box.
1 over 10.
Right. And in scientific notation, that's written 10 to the minus 1.
This right here.
All right. In decimal notation, 0.1.
0.1.
Yeah.
Okay.
Same thing. All right. Now, by drinking chocolate milk. So now we need a C.
Chocolate.
Right.
And that's
for centi.
Centi.
Like a century is for 100. And it takes 100 pennies. Pennies. 100 pennies to make a dollar.
Okay.
Right? We call the penny is 1 cent.
Okay.
Centi is 1/100th.
Okay,
so it's
1 over
100. In scientific notation,
that's 10.
10 to the minus 2.
Minus 2.
Because you notice there's 2 zeros in your denominator.
Oh, yeah, that's
10 to the minus 2.
All right.
All right. By drinking chocolate
milk.
So we need
it's easy to remember. I love chocolate milk.
I don't.
You don't, Miss Gray?
I don't like milk.
You don't like milk?
I don't know who decided to drink the juice that comes out of a cow's udder, but that's pretty gross.
Miss Gray?
It's gross. The abbreviation is lowercase m. And
that's 1
over 1,000.
1,000, 3 zeros, meaning to say the scientific notation is
10 to the minus 3.
Minus 3.
Great. So that's our smaller. Making the units smaller. So what we do with these are called prefixes. So we can adjust a meter to something smaller, like 1/10 of a meter.
Oh, yeah.
And so I'm going to show my hand. Here's my hand. And from my thumb to my little finger is about 1 decimeter. All right? So this is a good measuring device.
Okay.
I put this down and I know how long something is because if I keep my hand this way, it's 10 centimeters from one side to the other.
Yeah.
1 decimeter. Okay, now somebody with really big hands might have to squeeze their fingers together.
Yeah.
And someone with tiny hands might have to stretch.
Yeah.
But I've measured mine. I know from here to here is a decimeter.
A decimeter.
Right. If I hold my hand like this. So a centimeter is smaller. That's about the width of 1 index finger.
Okay.
If you have big hands, though, use your little finger. But get a ruler and see. How big is a decimeter?
Yes, a ruler is a good
And how big is a millimeter?
Yes.
Now a millimeter would be the thickness of a fingernail. It's the tiniest mark on the ruler,
tiniest mark. Okay.
right? So we can adjust the distance or length of something to be smaller.
To be smaller.
So
Units.
let's have units that get bigger.
Okay.
Okay.
So we're going from.
So now we're going backwards. Let's write
Okay.
across the top. King Henry died.
Okay. So I'm gonna start King
Mm-hmm.
King Henry. No, King Henry died.
Yes.
So I'm gonna start here.
Mm-hmm.
All right.
Great. Okay, now let's just write king first,
Okay.
just to
Start
help
with
it
the
make
king
sense.
first.
K stands for kilo,
Okay.
and kilo means 1,000.
So that's in scientific notation.
3 zeros.
T.
Yep,
All right.
10 to the third, and it's a
And-
lowercase k.
Is it a lowercase k?
It's
Okay.
lowercase, always.
That's lowercase.
Yeah, and I tend to loop the tops of my lowercase k's.
Like this one.
Uh-huh. Right, that way my students tell the difference between an uppercase and lowercase.
I write a different way, but yeah,
Yeah.
that's lowercase. Make sure that it's a lowercase.
Yes,
Okay.
that it's obvious.
Mm-hmm.
And then Henry, H is hecto.
Hecto.
A hectometer is 100 meters, 10 to the second.
10 to the second.
Yes.
And that's lowercase.
Lowercase h.
H.
Okay, and then
died.
died. D stands for deca, D-E-K-A. Like a decade is 10 years. So this is 10 to the first.
Okay, 10 to the first, 1 0.
Mm-hmm.
And
And its abbreviation is DA.
oh, DA.
Little d, little a. That way we can
Yeah,
tell
because
the difference.
yeah, D is deci, right?
Yes.
Okay, so DA.
So now we have all of our King Henry's method. If you don't know how to change one number to another, we ask King Henry
Ask King Henry.
which way to go.
He is reliable.
Right, right.
Okay.
And so now let's go smaller than that.
All right.
No, let's go bigger.
Bigger.
Yeah, since
Okay.
we can see that in your
Okay,
picture.
so let's
Okay, so bigger
continue with
than
bigger one.
kilo. We don't need to know all of the steps. Notice here we went 0, 1, 2, 3. Then
yeah.
when we went backward, -1, -2, -3.
Minus 3.
We don't have words for this next two steps.
I bet this is 4.
Mm-hmm. 4, then
this is
5. And then we're going to go to 6. So we're going to
Okay.
go 3, 6, 9.
Okay.
Right, so we can go 1,000, million, billion.
Okay.
All right.
All right.
So the next one is mega.
Mega. Like a mega star.
Right. And I bet our students are familiar with this term. It's 10 to the 6th, which means 1 million.
1 million.
And we use capital M, but they've seen kilobytes and megabytes. So what's bigger than megabytes on
Yeah.
your computer? Gigabytes.
Gigabytes.
So that's the next one.
That's the next one.
And that means a billion. So mega is a million. Giga
Okay.
is a billion. 10
So
to the
this is
9.
10 to the 9. And
Capital
this
G.
is capital G. Okay.
We cannot use lowercase g because that is
That's
for grams.
Grams. Okay.
Right. Capitalization counts.
Mm-hmm.
Okay, so now I think you have to move your paper over
All right.
so we can see things smaller than milli.
All right. I think that's good enough.
That should do it.
All right.
Okay.
So we have milk.
Yes.
What is after milk?
Okay, well then we have a -4 and a -5 step,
okay,
but
so
we
this-
don't know those words.
Mm-hmm.
So then our next big box is 10 to the -6.
Okay, and this we call it
Micro.
micro.
Like if you look
Which
through a
is-
microscope, you'd be measuring in micrometers,
Mhm.
right? And it has a goofy symbol.
I know.
It's that Greek M.
Oh, is that Greek
Yeah.
M? Okay.
So let me use
Which
your
means
pen,
micro.
and I'm going to show them how to write this.
Okay.
You have a U, and then put a tail in front. That's how you write micro.
Okay.
Okay.
Thanks for teaching that, Miss Gray. All right.
Okay, then we would go 10 to the -7, then -8, and the next one we know
Next
is
one is-
-9.
And we call it
Nano. Everyone has heard of nanotechnology. This is on a small scale of 10 to the -9.
Okay.
Okay, so a lowercase n, not a capital N. And then,
9, 10, 11. I bet this is 12.
yep, the smallest one they need to know is called Pico.
Pico.
P-I-C-O. In Spanish, what does Pico mean?
What is that? I don't know.
Small.
Oh,
or
small.
little.
Okay.
Mhm, yeah.
Pico means small.
And it's a small p,
small p.
lowercase p.
Lowercase p.
And that's our
That
abbreviations.
completes our
Right. So now let's look at base units besides these three: meter, liter.
meter, liter, and
gram.
grams. Okay.
Okay.
We have more than
Yeah.
that. Okay.
Okay.
So I'm going to move my paper
All
so
right.
they can see.
Good. Under the part where it says different types of basic units.
Okay, different types of basic units.
Of course, we defined 3 already.
Okay.
Meter
Mm-hmm.
has the abbreviation lowercase m.
M.
Liter,
Why did I put equal?
oh, that's
Just
fine.
enclose that in.
Yeah.
Okay, and then liters.
That has a abbreviation of capital L
Mm-hmm.
because a lowercase l looks a lot like the number 1. So we use capital L.
Okay.
Okay. And then
we have
gram,
gram.
and that's going to be lowercase g.
Okay, we're talking about base units, right, Ms. Gray?
Right. And the SI unit for grams, for mass is kilograms.
Mm-hmm. So I'm going to write kilogram here.
Right. But
Which means that
kilo
this is...
has been, it's been modified with that prefix
Okay.
kilogram, right?
Kilogram.
1,000 grams.
Okay.
Okay, so
Let's
in
continue.
SI, mass is kilograms.
Kilograms.
All right, amperes we discussed is for electrical current.
Mm-hmm.
That's capital A. So we could have milliamps and microamps. We could have mega amps. But what's most common that they'll see on their electronics, like on a hair dryer or a washing machine or their
Amperes,
iPod,
right?
they'll see milliamps.
Oh.
Yeah.
Okay.
Commonly.
Okay.
And then for time,
Mm-hmm.
the abbreviation is a lowercase s, not SEC.
This is for time.
Mhm, so just
Lowercase s.
Yes, and that's all.
Okay.
All right, we don't use SEC,
Mm-hmm.
just the S.
Okay.
And so if you have microseconds, you put the mu, that goofy Greek M, and an S, microsecond.
All right.
But if you wanted more than a second, we don't use kiloseconds. We use hours and minutes.
Oh, yeah.
Days.
Kiloseconds doesn't make sense.
Right.
Okay.
Okay, there's
I'm
2
gonna
more.
Move my paper a little bit.
All right.
There we go.
2 more.
2 more. We have...
For measuring the amount of substance, we use
Mhm.
moles, and its abbreviation is just MOL.
Yes.
That doesn't save you a lot of writing.
Exactly.
Yeah, MOL. And then candela
Mhm.
is for luminous intensity to measure brightness of light.
Okay.
We use lowercase c, lowercase d
Yes.
for candela.
Mm-hmm.
Okay, so those are our basic units in the SI system.
Right.
Everything else is derived from these units.
From these basic units, right?
Mhm.
Okay.
Okay, let's look at how to
Alright.
measure temperature.
Okay.
When measuring temperature, we will use units of Kelvin.
And we're going to talk about this in chemistry, right?
Right, we're
Okay.
going to see the liquid nitrogen demonstrations
Yes.
so that we can see
Okay.
how we mean by temperatures.
Mhm.
All right, so to find Kelvin, take your degrees in Celsius
All right.
and add 273.15.
All right.
Okay, and Kelvin doesn't get to have a little circle.
Yeah.
Only Celsius and
Mhm.
Fahrenheit do. And to change Kelvins to Celsius, we do K minus 273.15.
All right.
So that's pretty simple.
That's easy.
And then absolute zero is what we call 0 kelvins, and that is the point in temperature where molecular motion theoretically stops.
Okay. Molecular. I hope they can read my handwriting. So I'm trying to write really, really small. Motion theoretically.
Theoretically stops.
Oh, this is E.
And what we mean by this is that the molecules stop vibrating, the nuclei stop flipping around, and even the electrons stop orbiting the nucleus. Everything stops moving.
Okay.
And the temperature that we call it there at absolute zero is going to be 0
Kelvin
or negative 273.15 degrees Celsius. Yeah. All right. Now, converting from Fahrenheit to Celsius is something they'll only have to do with the formula in front of them. We're going to show them how to do this in class, but let's write down the formula to help us out. So it's 9/5 times your Celsius temperature plus 32 degrees.
32.
Okay. Then the next one
Is
I have a mistake on here. We have to use parentheses.
here.
Yes. So we take our Fahrenheit temperature minus 32 degrees first. Do the subtraction first.
Okay.
Okay. And then multiply that difference by 5/9.
Okay, so I'm going to write degrees Fahrenheit first, right? Minus
32.
32.
And put it in parentheses
Multiply it by
5/9.
5/9.
Right. Now, the order of operations makes a difference.
Yeah.
Right? So make sure you subtract first and then multiply.
Then multiply.
Okay.
Okay.
Good. So that's how we do temperatures.
All right, that's temperature.
Good. In our next section, we're going to look at converting American units to metric units. And we're not going to do much of this, but just a little bit.
Yeah.
Okay. So where it says
and
other,
it's very important that they know this.
Yes.
You know, because they're going to use this when they're going to maybe travel or...
Yeah, right. Or just out in life in general.
Exactly.
In a chemistry lab, some of these will come up. Okay, so 1 inch is our first one.
Okay.
And I'm going to show everybody what 1 inch looks like.
Okay.
Okay, so I'm going to put my finger here.
All right.
All right, if you bend your finger here, this bone is a standard bone in the human body. So for every adult, unless you have really big or really small hands, that bone is 1 inch.
Okay, let's try to...
Yep, it's the same.
It's the same?
Yep. 2.54 centimeters
All right,
is 1 inch.
2.54.
So if I ask you to have 2 centimeters, you can use this as a measuring device. This is 2.5 centimeters, so almost this length of your finger will
That's
be
1
about
inch.
2 centimeters.
Okay.
So know what your measuring sticks are. Here was one ruler, and here's another ruler for me.
Yeah.
All right.
We can actually use our body to
To estimate. Good.
Okay.
Now 1 pound is 4.52.
0.8.
I'm doing it so wrong.
452. That's okay, Miss Gray.
0.8.
They will understand. It's really late, you know, but
It's-
we're good. We're still good.
Yes.
Okay,
Brain's not
1
working.
pound is equal to 452.8 grams.
Right. And that means it's less than half a kilogram to make 1 pound.
Yes.
Because 1
1 kilo is
kilo is 1,000 grams.
grams.
And so half would be 500 grams.
So less than 500 grams is 1
Right.
pound.
It's about 2.2 pounds per kilo. All right. So if somebody weighs 100 pounds, that's very different from weighing 100 kilos.
Oh, yeah.
Yeah. Okay. Let's look at a gallon.
Okay.
1 gallon.
There's the bell.
This is backwards. 1 liter is 3.78 gallons. No. It's right.
1 gallon is
1 gallon
3.78 liters.
is 3.78 liters. It's
Okay.
4 quarts to a gallon, and
Okay.
a liter is almost a quart.
Okay.
Wow, I'm confused. I need a nap. I've been up since 5.
You're just ready to call it a day.
Yes.
But we need
one-
to finish this, Miss Gray.
Okay, this one we're going to use a lot, so we better get this in.
Yes.
1 milliliter is equal to 1
1
cubic, centimeter.
centimeters.
All right. So that we're
Are
going
you
to
going to
use
show
so
them
much
an
that-
example?
I'm going to show them an example
Okay.
that I have right here. So go ahead. We'll keep on doing a mile.
Okay,
Next.
mile is equivalent to 1.6129 kilometers. Let me just move my paper so you can see clearly.
You know, a lot of our track kids will know this. But most of our students have had to run a mile in school, and they know that's 4 laps around the track.
Yeah.
That's a 1,600. And it's actually 1,613 meters. So when they're running a 1,600, they're getting away with 13 extra meters that they don't have to do.
Yeah.
Okay, here I got my cubic centimeter.
Okay.
Okay, so I've brought this out so that we can see 1 cubic centimeter is the same space as 1 milliliter. If I put a milliliter of water, it would make the same space
As
1 cubic centimeter, where it's 1 centimeter on each side.
Yeah.
So that's a cubic centimeter. Okay.
Now you have an idea what 1 cubic centimeter looks like.
Yes.
Okay, now we're done with mile to kilometers.
Okay, ounces to grams.
All right.
If you were holding in your hand about 28 paper clips, then you would have 1 ounce.
Yes.
Yeah.
Paper clip.
28.3 grams is 1 ounce. Now, fluid ounces are different.
Yeah, this is solid, right?
Yes.
28.3.
Right, by mass. A
by
fluid
mass.
ounce, like a 16-ounce soda, right? That's what we're looking at here now. 29.57 milliliters makes up 1 fluid ounce. Okay, now for time. I bet our students know this.
Oh, yeah.
How many minutes are in an hour?
60.
How many seconds in a minute?
3,600 or 3,600.
Right, 60 seconds in a minute and 60 minutes per hour. So 3,600 seconds in 1 hour.
All right.
Okay, now for unit conversions, I think let's go ahead and work through some of these.
All right.
Okay.
Let's finish this.
Some but not all.
Okay.
Because our students need a chance to practice.
Yes.
All right. Well, how should we have room to
we
write?
need to.
You know what? We can not use the bamboo. We'll do this.
Okay.
Okay. So if you'll show the work above, we'll answer that question.
Okay.
1,000 milligrams to 1 gram. So we'll use the King Henry's method.
Okay.
And we're going to start with 1,000 milligrams.
Okay.
So write the number 1,000. Okay. Now look at our steps in the ladder.
Okay.
Can you show us our steps?
All right.
Our staircase.
Let's move down.
Okay. We're going from milli to grams.
Okay.
Okay. How many spaces? How many steps? 1, 2, 3.
3.
To get all the way to grams. So we start here. 1, 2, 3 steps. All right. So here's your work again.
Okay.
We're going to move 3 steps, and we move to the left
Move to the
because we
left.
were going upstairs.
It's right here.
3 decimal places
1.
to the left. Right. So 1,000 milligrams is
Is
equal to
equivalent to
1 gram.
1 gram.
Yes. And let's go ahead and keep the zeros since they gave us the zeros. So we'll call
Okay.
it 1.000.
1.000.
Because if we know we have exactly 1,000 milligrams,
Yeah.
then we know we have 1.000.
1.000 grams. Okay.
All right. Let's try centiliters to nanoliters.
Okay.
So in our staircase, find centi.
All right.
And I think you have to come to your left.
Oh,
in the
yeah.
picture.
Okay.
So here's centi, and where's nano?
Nano is right here.
Okay, so we can't skip any steps or you'll fall down.
All right.
Okay, 1, 2, 3, 4, 5, 6, 7. We're going to go 7 steps to the right.
To the right.
Okay,
So
so
here
start
is-
with the number you had,
Okay.
0.736.
Okay.
Moving the decimal 7 times
To the right.
to the right.
1, 2, 3, 4, 5, 6, 7. I'm going to put 0.
Yes.
There you go.
Okay, good. So that looks like 7,360,000. Well, you're going to have to write really tiny to squish it all in. Huh?
Oh, yeah. So many 4s?
4
zeros.
zeros.
2, 3, 4. I did it.
Great.
All right.
Okay, let's try the next one. Use your
Okay.
staircase. Find grams to kilograms.
Okay. Grams.
Grams is a basic unit.
I think I need to move my paper so they can see it. Hopefully this works.
There.
There you go.
Okay, so we have grams to kilograms.
Okay, how many steps?
1, 2, 3.
3.
Okay, we're going
And then
3
we're
times
going
to the left.
Okay, let me show you. So that's 109.
Okay,
And then that's 1, 2, 3.
yes.
All right. And that's going to be, should I write 0?
I like to write the 0
Okay.
as an indication
That there is a
that
decimal
there's a
place.
decimal. That makes people look for the decimal better.
Yes. So that's 0.109 kilograms.
Right, and that should make sense that grams is smaller than kilograms, right? So that should be a small number now.
Yeah.
Where nanoliters is smaller than centiliters, so when we're going backwards, we get bigger numbers.
Bigger numbers.
All right, let's do one more.
One more. Which
And-
one do you want?
Let's do
This one is
decagrams to
easy.
megagrams because we haven't done
Okay.
very many on that side of our
Okay.
staircase.
We're going to do this.
Yes.
All right.
783
Let's show them. So that's
decagrams to megagrams.
okay. Where's our deca? Here's our deca. Let me move my paper. We're doing a lot of movement here.
So here's
right.
deca, and then here's mega. All right, how many steps? Don't forget the black
Okay.
steps.
1, 2, 3, 4, 5.
Yes, 5. 5 steps ought to get
Okay.
us there.
Let me
Okay,
move my
show us your
paper.
work.
That's
I think we have to scoot up higher.
okay. Oh yeah. So that's 783, and we're moving to
5 spaces to the left.
all right. So that's 1, 2, 3, 4, 5.
Okay.
Okay. I'm gonna put 0 and then my decimal point 00783.
Yes, that ought to
Okay.
do it. Okay, so that's how we'll do these. We'll expect our students, of course, to show us the rest that we didn't do with
Okay,
them.
they're going to do this for 3 right here and then 2.
Yes, and to be able to show us how they got the answers.
Yes.
Not just the answer, but how they got it.
yeah, using our King Henry
Right.
okay
Using the staircase
staircase.
and King Henry.
All right.
Okay, well, We'll have lots of practice in class. See you
Yes.
next time.
Yep.